Hello. This will be a demonstration of Proposition 20 of Book 10 of Euclid's Elements, which says that if a rational area be applied to a rational straight line commensurable in length with the given rational straight line is produced as breadth. This is the converse of the previous proposition 1019. We're given a rational straight line AB. And we will apply the rational rectangle, the rational area, here it will be a rectangle, the rational rectangle AC to the given rational straight line AB, like so. And this will produce as breadth the line BC. That is to say, the rational area AC is contained by AB and BC. And since it was applied to AB, we call BC the breadth. It is produced as breadth. And what we want to prove is that BC is rational and commensurable in length with the given rational straight line AB. We will begin by constructing the square AD on AB. We can do this according to Proposition 146. Now, because AD is the square on a rational straight line, we know by definition 10.4 that the square AD is itself rational. AD is a rational area because it is the square on a rational straight line. But AC was also given as rational, so AD and AC are commensurable with each other because they are both rational. But the square AD is to the rectangle AC, just as the straight line DB is to the straight line BC. We know this from Proposition 6.1. These are two parallelograms, the square AD and the rectangle AC. Those are both parallelograms. And they're under the same height, or they're in the same parallels, because this straight line is parallel to DBC. And so they are to each other as their bases. The base of the square AD here is DB, and the base of the rectangle AC is BC. So the square AD is to the rectangle AC, just as DB is to BC. But remember that the square AD and the rectangle AC, those are commensurable with each other. They're both rational, so they're commensurable with each other, which means, according to Proposition 10.11, because AD, the square AD is to the rectangle AC, as the straight line DB is to the straight line BC, and the square AD is commensurable with the rectangle AC, therefore follows, again by Proposition 10.11, that DB is commensurable with BC. But because AD is a square, we know that AB is equal to DB, just by definition of a square, definition 122. So that because DB is commensurable with BC, AB, which is equal to DB, AB must be commensurable with BC, which then means not only is BC commensurable in length with AB, but because AB is a rational straight line, and we know from definition 10.3 that any straight line commensurable with a rational straight line is itself also rational, because AB is commensurable with BC and AB is rational, therefore follows that BC is rational, which is what we wanted to prove. So we're done with the proposition, therefore, etc., QED. I don't have anything to say about this proposition, so I'm going to end the video here and move on to Proposition 10.21.